Hello, and welcome back to Shiksha DaCosta. Today we're going to introduce you to a new unit called Using Analytic Geometry to Verify Geometric Properties. So in this unit, we're going to learn how to verify the properties of geometry, especially looking at triangles and quadrilaterals. And we're going to do that using a technique called analytic geometry. Specifically, we're going to determine some of those characteristics and properties through an investigation, and then we're going to verify those using algebraic techniques. And by the time we're done that, hopefully you have learned and you're ready to make your own plan, to plan and implement a multi-step strategy that uses these techniques to verify a property about triangles or quadrilaterals that you have determined is probably true. Now you're going to learn how to make sure that that actually is the case. This is a little bit of a research project that I've got for you here. So before we start the unit, it's really important that as we're going through the unit, you're able to understand all of the words that we're using to describe the current situations. It's really important that at that point you're not stopping and being like, hey, what does that mean that he just said? So right now, what I'd like you to do is find the geometric definition of each of these terms that we're definitely going to use. And when I say geometric definition, that word there is not there by accident. There are some of these words, like median, that actually have a definition that is from data science. But we are looking specifically for the one that applies to geometry. Once you're done looking them up, and let's do this just one at a time. So look up the definition of slope and then write it down in your own words. And that step is really important for helping you process the information. If you need to, please feel free to use a diagram. Pause the video here and do that for slope, and then once you're done that, move on to midpoint and then keep going until you're done all of them, and then resume the video here once that's done. Okay, well, for me, the slope of a line is a rate comparing the height of a slanted line. So let's say I've got a line that goes like this. I want to compare its height, which might be this distance right here, to its horizontal length, which might be this distance right over here. For me, that rate is the slope of a line. The midpoint of a line for me is a location in the exact center of two others. So in the exact center of two other points, so I might say that there is a point at the end of my line that I've already got drawn here. Let's say that's a point right there. And that's another point. The midpoint would be right over here in the exact center. And another way to confirm that is the distance to both ends is equal. And the way we show, oh, sorry, I already used green. Maybe I'll try a different color here. Let's try orange. The distance to both ends is equal. And what I mean by that is, notice I'm going to put two very small lines, two notches on each of these. In geometry, whenever you put a little notch, that means that that line segment is equal in length to any other line segments that also have one notch. If there were two notches, then all the line segments with two notches would be indicated that they are equal in length. Moving on, the median of a shape, and you know what, let me get rid of my diagram. Pause the video here if you need to copy down this diagram. All right, let me erase that now. The median of a shape actually is in a polygon. It's a line connecting a vertex to the midpoint of the side that is opposite it. And that's usually for triangles. And so if I want to draw a little diagram of that, maybe I'll draw a triangle like this. Okay, and if I choose a vertex, maybe I'll choose this vertex right here, and I connect it to the midpoint of the side that is opposite it. So let me highlight the side that's opposite that purple dot. That would be this side right over here. And the midpoint of that side would, of course, be right in the center, maybe like right over there. And so the median is the line that connects these two just like that. Right? So that would be the median, a line that connects one vertex to the midpoint of the side that is opposite that vertex. A centroid is the balance point of a shape. In other words, the average of all points in the shape's area. So for example, if I had a square and I had this maybe a square made out of cardboard and I was trying to balance it, I would probably put, maybe on a pencil, I'd probably put the pencil right over here, and hopefully the square wouldn't tip to any side. And this is a mathematical definition for this would be that this point is the average of every single point that is in the shape's area. And because all of them are sort of pulling it equally in all directions, the square could balance perfectly on this point. And that point right there is called the centroid. Concurrent, or excuse me, diagonal. A diagonal is a line that connects 2 points of a quadrilateral, but not the edges. So if I had a quadrilateral, and I'm going to make a really sort of weird one right here. If that's a quadrilateral, the diagonal would be this line right over here, or maybe this line right over here. Those are the diagonals of that quadrilateral. So a line that connects 2 points, but not the edges. Concurrent is a adjective. It means a point where 3 or more lines intersect. So if I were to extend the diagonal here a little bit, and I were to extend the side lengths a little bit here, just sort of like that, then I would say that this point right here is concurrent to all 3 of those lines. So it's a point where 3 or more lines touch each other. A parallelogram is a very specific type of quadrilateral. It's a quadrilateral where any of the opposite sides are parallel. And let me just draw an example of that for you. So this side, because it's sort of going in, let me put that in another color, in this direction, well then I need another side that's also going in that same direction. Whenever you see this notation here, an arrow, any 2 sides that have the same number of arrows, any 2 lines that have the same number of arrows, are going in the same direction. They are parallel to each other. But for a parallelogram, not only do the opposite sides need to be equal, but any side that is opposite another needs to be parallel. Sorry, not equal, but parallel. Although I guess technically in a parallelogram, the opposite sides are equal as well. So maybe if I connected these like this, you can see that both those 2 sides are actually heading in the same direction as well. And I'll show that they're going in the same direction as each other, but not the same direction as these by drawing, double arrows on them. That right there is a perfect example of a parallelogram. A rectangle is a quadrilateral with 4 right angles and where the opposite sides are equal in length, and that's a shape you should be really, really familiar with. A trapezoid is slightly different. It's a quadrilateral that has 2 opposite parallel sides and well, maybe more than that. I guess technically it doesn't really matter if the other sides are parallel or not, but certainly if we have, for example, a side length that looks maybe like that and another side length that maybe look like that, and then we could connect those sort of this way. In a parallelogram, only 2 side lengths are in a trapezoid, only 2 side lengths would be parallel. In a kite is a quadrilateral with 2 pairs of equal side lengths that are actually not opposite each other. They're adjacent to each other. So I might draw a kite somewhere like this, like these 2 sides right here. They have the exact same length, and these 2 sides, the other 2 sides, also have the exact same length, but they are not opposite each other. Instead, they are touching each other, or they are connected at one vertex. An isosceles is actually another adjective along with concurrent over here. It's one of the few adjectives on this list. And to be isosceles in geometry is to have 2 or more sides with equal lengths. So you may be familiar with the most famous of these. This is an isosceles triangle, right? So right here we have a triangle where this side and this side are the exact same length. And in fact, not only are they the same length, but this angle and this angle are also exactly the same. And this is how you might denote that an angle is the same as another one. You might put a little circle in there. There's actually many different notations or ways to do that. You might put a little X. You might draw an angle measure, just sort of like this. And you might, sorry, let me just draw another one here. Another angle measure just like that. And you might put the same way we mark a side length, we might put a single notch to indicate that these two angle measures are exactly the same. And if you have two side lengths that are the same, that's an isosceles shape. And finally, a chord in geometry, not in music. In music, a chord is two or more notes struck at the same time. But in geometry, a chord is a line that connects 2 points on the circumference of a circle. So let me just draw a quick circle here. Please excuse. Well, actually, that's turning out to be not too bad. Any 2 points on the circle, not necessarily the points at the ends, but even this point and this point right here, if we were to connect those with a line, that right there would be a chord. And now, hopefully, your definitions, or in your own words, match these in some way, shape, or form. If they didn't, then please go ahead and amend them right now to make sure that when we use any of these words throughout this unit, we are describing them in the exact, we're using them in the same context, we're on the same terms. In this next activity here, what I'd like you to do is check out, maybe copy down this chart here, and check off the boxes, just put a check mark in there, where the shape at the top matches the criteria on the left. And once you're done that, go ahead and resume, pause the video here to go do that, and then once you're done, resume it, and I'll take these up. Okay, I'm going to just go one shape at a time. So in this triangle here, I can see that none of the sides are in the same direction, so they're not parallel. I also don't see any right angles, but all three of these sides do look like they are the exact same length. So there are 3 equal sides here. It also looks like all three of the angles are the exact same as well. And this, just going through the rest of these very quickly, this is definitely not a rhombus. Scalene means none of the sides are the same, so it's not scalene either. It's not a parallelogram because that's quadrilateral. Is it isosceles? In the case of a triangle, I guess technically it is isosceles, but in the case of a triangle, usually we don't use the word isosceles to mean all 3 sides are the same. We just use it to indicate that when two, not more than two, just 2 sides are the same. So in this case, we wouldn't call this isosceles, although some people might, and you know what, more power to them. A kite, a rectangle, a square, and a trapezoid are all quadrilateral. So this is definitely only 3 sides, only a triangle. And we might indicate the equal sides and angle measures just as such. For our next shape, it's also a triangle. There are no parallel sides and there's no right angle, but it does have equal sides. In fact, 2 of these sides here are equal, and it does also have 2 equal angles. It's not a rhombus because that's a quadrilateral, and this is not a scalene triangle because it does have equal sides and there's 2 of those, and it's not a parallelogram. This is exactly an isosceles triangle, but it's not a quadrilateral, so none of these will be true. That little angry guy there is our isosceles triangle. The next triangle that we're looking at here doesn't have parallel sides, but it does have a right angle, and it has only one of those. None of the sides are equal, and none of the angles are equal either. So we might call this a scalene triangle. It's both scalene and right. It's not a parallelogram, and it's not isosceles, and certainly none of the other quadrilateral properties apply. The next one that we're looking at, very similar to this one, has no parallel sides. It does have a right angle, but it actually does have 2 equal sides, this one and this one. And therefore, it has 2 equal angles as well, this one and this one. And this is, it's not a rhombus, it's not scalene because it does have 2 equal sides, it's not a parallelogram, but it is isosceles. So this right here is a right isosceles triangle, and definitely not a quadrilateral, so none of these. The last triangle we're looking at here doesn't have parallel sides or right angles or equal sides or equal angles, and therefore we would call this scalene. And it's not a parallelogram, it's not isosceles, and it's not any of the other quadrilaterals either. Now moving on to the quadrilaterals, this one right here does have parallel sides. It has 2 pairs of parallel sides. And it doesn't have any right angles. Actually, these two sides and these two sides do look like they're equal to each other, so there are also two pairs of equal sides. It also does have equal angles, and that angle and that one, that's a pair. And these two are also equal, or actually, at least they look like it. It's not a rhombus, because for something to be a rhombus, all the sides do need to be equal. And it's not scalene, because actually there are some equal sides. Remember, anything that has equal sides can't be called scalene. This actually is a parallelogram. And is it isosceles? Technically, yes, because once we move on from triangles, the word isosceles means at least two side lengths are equal. These two and these two. And we can see that's true right there. So unlike triangles, if a polygon has at least two equal sides, it's also going to be isosceles. This is not a kite, according to our definition. It's not a rectangle because there's no right angles, or for the same reason, it's not a square, and it's not a trapezoid either. Sorry, I'm so sorry about that. Yes, actually, it is a trapezoid, because the definition of a trapezoid is it has two parallel sides. Like over here, we're going to get to that a bit later. We can see two parallel sides make a trapezoid, and this does have two parallel sides. Even though the other two sides are parallel as well, that doesn't stop it from being a trapezoid. In geometry, we have exclusive and inclusive definitions. And the inclusive definition of a trapezoid is the more modern one. It's the one that we use these days. It's any shape that has two parallel sides, and this would be one example of that. Our next shape here is, and sorry, before I get into that, notice how complicated this diagram here is for this parallelogram. These two sides equal and parallel, these two sides equal and parallel, these two angles equal, these two angles equal, but not equal to each other. Next up, we have this shape right here, which does have two pairs of parallel sides, this and this, and this and this. It does have four right angles. It has two pairs of equal sides, and of course, all four angles, because they're all right, they're all equal. All of them are 90 degrees. It's not a rhombus because it doesn't have equal side lengths, all four equal side lengths. It only has two pairs. It is not scalene because it does actually have equality within its pairs. It actually is technically a parallelogram because these two sides are parallel and these two sides are parallel. That makes it also isosceles because it does have equal sides as well. It's not a kite because to be a kite, and actually this is a kite right here, the adjacent sides need to be equal. Of course, this is our rectangle. It's not a square, and it is technically a trapezoid. And that's its diagram right there. Almost as complicated as the parallelogram, but because it has these right angles here, that makes it a little bit easier to digest. Next up is this shape over here, which does have two pairs of parallel sides, four right angles in all the corners, and all four side lengths are equal. And of course, all four angles are 90 degrees, so those are equal as well. This is a rhombus. And the definition of a rhombus is just a quadrilateral with four equal sides. And of course, we can see that that's already true. It's not scalene because there is equality among some of the sides. And it is a parallelogram because the opposite sides are parallel. It's isosceles by that same definition that we've been using so far. And is this a kite? Technically, yes, it is, because the adjacent sides are equal to each other in length. It's also technically a rectangle, even though it has different side lengths. That's not really a definition for what a rectangle is. A rectangle just has to have all four right angles. And the actual label for this, of course, is a square. And technically, also, this is a trapezoid because it does have two parallel sides. Next up, we have this shape over here, which has two pairs of parallel sides, but no right angles. However, all four sides actually are perfectly equal. And although it has two pairs, this and this right here, of angle measures that are equal, because of that, because all four sides are equal and it has two pairs of equal angles, not all four, that stops it from being a square, but it does allow it to be a rhombus. It's not scalene. It is a parallelogram because actually these two sides are parallel and these two sides also are parallel. And it is isosceles because it has at least two sides equal. Um, it is technically a kite as well because adjacent sides are equal. It's not a rectangle because it doesn't have 90-degree angles or a square, but it is a trapezoid because it does have two sides that are parallel. Next up, we have actually the most basic form of a trapezoid. This does have only one pair of parallel sides, and that's all you need for it to be a trapezoid. There's no right angles that I see in this shape, and there's no equal sides, there's no equal angles. It's definitely not a rhombus, and because there's no equal sides, we can safely call this scalene. Not all trapezoids are scalene, but if it doesn't have equal sides, that's what makes it scalene. It's not a parallelogram because these two sides are clearly non-parallel. It only has one pair of parallel sides. It's also isosceles because it actually does have two. Oh, sorry, it's not isosceles. I was thinking about parallel. It's not isosceles because all four sides are unequal. So we can say that it's scalene, and we can see across all of these, if something is isosceles, it's not going to be scalene and vice versa. Is this a kite? No, a kite needs to have two equal sides. It's not a rectangle or a square because there's no right angles. This is the actual basic definition of a trapezoid, two parallel sides. This is also a trapezoid. It does have two parallel sides. It has no right angles. But if you notice here, actually there are two equal sides, a pair of equal sides in this trapezoid. And that also means that there are going to be actually two pairs of equal angles, this one, and this one is equal to this one right there. So that, well, it doesn't make it a rhombus. It's not scalene anymore because actually this side and this side are equal to each other. It's not a parallelogram, but the fact that these two sides are equal makes this an isosceles trapezoid. It's not a kite because we don't have two sides that are two pairs of sides that are adjacent and equal. It's not a rectangle or a square because there's no 90-degree angles, but we would call this an isosceles trapezoid. And finally, we have the kite. So this does not have any parallel sides. I also don't see any right angles. There are equal sides, so this and these two sides, the top two are equal and the bottom two are equal as well. There are also just a single pair of equal angles, this one and this one right here. It's not a rhombus because all sides are not equal. It is not scalene because we have two equal sides. It's not a parallelogram because all of these are heading in different directions, but it is isosceles. These two sides and these two sides being equal make it an isosceles shape. This is a kite. It's not a rectangle or square because it doesn't have any 90-degree angles, and it's certainly not a trapezoid because there are no parallel sides. So there you have it. These are all of the shapes that we might encounter throughout this unit. And here we have some diagrams of them in case you didn't want to have this entire chart to refer to. You should be able to understand all of these just by looking at these diagrams right here about how many sides are equal, which sides are parallel, which sides are perpendicular to each other, etc. So that was quite the introduction there. In this, I hope you realize that we can take a shape and classify it by all sorts of different things, by its side lengths, by its angle measures, by the size of either of those, and the direction of those sides. If we were to put these shapes on a coordinate grid to define their vertices, then you can actually connect those vertices to draw a shape. And using that, you can calculate the length of any side, the slope of any side, the midpoint of any side, or even instead of looking at any side length, we can even look for the length, slope, and midpoint of the medians or the diagonals of that shape. We can also find the measure of any angle. And we can do that just using some algebra. And once we're done that, we can actually use those properties to classify the shape or to verify that each of these properties is actually true.
If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.